Okay, good afternoon, good morning, depending on where you are, everybody. Adrian Gosbell here. Sat in my office in Amsterdam with Mike Taylor and Tom Shaw, and today we're going to give a lecture session on JSON Web Tokens, which is part of our ongoing theme around security, which we've had a couple and we will continue with some more. This is quite an interesting session, which is very important if you're doing anything around integration using web services. Also becomes interesting around web in general. We did this session this morning. We actually had quite a few ongoing discussions with a few of the participants after the session had actually officially ended, which was also quite encouraging. It told us it was an important topic. Tom's going to be delivering this session, and I will hand over to him and he can take it from there on.
Good morning and afternoon, everyone. I'm Tom Shaw. I'm a Uniface SME based out of the States. I am here in beautiful Amsterdam. It's not raining today, which is shocking. Pretty straightforward agenda. I'm going to talk about JSON Web Tokens, how they play with Uniface, the technology in the Uniface stack that allows you to implement those. I've got a sample application and test set and some other industry information. If you have questions, please go ahead and pop them into the chat session. They'll be forwarded to me. I'm more than happy to answer questions as we go along rather than holding them to the end. I don't want someone to have a question out there and not get answered. If it can't get answered right now, we will go ahead and follow up if that's okay. Let's kind of start off with, so what's the problem? There are two aspects. One is authentication, and the other one is information sharing. And I'll drill down on authentication first. So the specific authentication and or authorization technologies out there are SAML, and you can think of this for specifically single sign-on. This is a specification that vendors implement. So whether it's a Microsoft stack, IBM, etc., it gives you the ability to go ahead and do single sign-on and, believe it or not, single sign-off. So it gives you the capability to disconnect from all the systems as well. The other one is OAuth. Think Google, think Facebook. Noticeably in that technology, it gives applications and providers the ability to share information. And then there's OpenID, which can be coupled with OAuth as well, but it's designed to go ahead and allow a third party to go ahead and authenticate who you are. I'll get into some details around it. But really it comes down, when we're talking about JWT, we're talking about a requirement that I need to be able to share information in a trusted way. Notice I'm not saying secure, I'm saying trusted. I need to verify that what I send has not been intercepted and modified along the way. It also needs to be non-complex. So when I talk about SAML, you'll see that it's a very heavyweight, very powerful, but very complicated mechanism for dealing with authentication. So we need a way to go ahead and send information around that's not going to require, a stack of libraries out there. And it needs to be supported by multiple languages, hence multi-client. So, think not just C# Uniface, but also think CGI, Perl, CURL, etc. SAML 2 is an extensive mechanism for dealing with authentication and authorization. It is by no means lightweight. It's been around for a fairly long time and is in use in a lot of places. It's fine for doing heavyweight stuff, but when I start talking about web technology, we want the ability to do this in a lightweight fashion. Similarly, OAuth solves a particular problem. The idea is that I want to be able to grant access to applications and information without divulging my password. So when I go to Facebook or I log into Facebook via another application and use my credentials, that third party is not getting my password, but they are getting the ability to look at my information. I'm sure those of you who are on Facebook have seen, you know, by doing this, it's going to give you access to your friends list, contacts, etc. It's fairly complex because it solves a complicated problem. It is based around authentication and, to a certain extent, authorization. The difference between those being, I know who you are, is authentication, and authorization, what are you capable of doing? Now, it's nice because I don't have to share my password, but there's also the downside that allows, you know, other people to share my information, which I may choose not to desire. OpenID is also a standard. It is not as popular as the others, although OAuth and OpenID can work together. But the OpenID piece gives a way to federate authentication to a third party. So rather than writing my own user and password authentication system, I can use OpenID to go ahead and provide that service for me. It also does not have anything to do with sharing between those providers and consumers. So all it is doing is providing that authentication match that says, based upon my credentials, I am who I say I am. Why do you care about this? Well, certainly it is a web standard. The ability to move information around in a secure way is a good thing. Certainly other technologies, if you're going to interact with them, they expect you to be able to do this type of stuff. Certainly Uniface is web aware and web capable. So it means I have the ability to utilize web standards in a Uniface way as opposed to going to low-level technology. And in addition, it means I don't necessarily have to go directly to JavaScript, which was one of the questions this morning. That, you know, oh, this is all being done in JavaScript. The answer is no, it's not. The important takeaway right here is that there is no out-of-the-box statement for JWT. Not with us and not with anybody else. So, you know, you're not going to find a proc statement to do this. What you will find is the technology to be able to implement it, and that's what we're going to talk about and demonstrate. I brought up the definition for a reason. This is an internet standard. There's a request for comment out there describing in excruciating detail what JSON Web Tokens are. There are a set of claims with a JSON object and JWS and JWE. If you can see that little block, the reason why I left it like that is I wanted to make sure that you saw the original Klingon text, because quite frankly, that's what it behaves like when you read the actual specification. It looks like this. Now, as it is a specification, they go into you know, pretty detailed implementation stuff about the description of it, what it includes, how it behaves, including how it's pronounced. So JWT is pronounced JOT. It's interesting because they describe everything in a technology neutral way, meaning an implementation language way, so that you can go ahead and implement it. In fact, I want to do some definition here because this also came up. You know, with JOT, they talk about a claim, and the specific definition of that claim that I want to use is it's an assertion of something as fact. So I claim this to be true. It's part of that set of issues that I'm going to deal with JOT. In fact, in Uniface speak, you can think of this as a name-value pair. So I've got a item and it has a value. The analogy I'm using is that JOT is like a medicine bottle in that it is somewhat tamper-proof. And those of you that, you know, go to a pharmacy and pick up medication, you know, it's going to have that child-proof cap, but it doesn't have the foil seal. So I'm trusting that the pharmacist put the right stuff in the bottle. I know it's labeled. It can be traced. It was filled at this particular pharmacy. I know who prescribed it. It's got the doctor's name on it. I can see what's in it. What I can't tell you is the medication correct, hence the trust. I'm assuming that they put the right medication in the bottle, unless, of course, the pill's got, a label on it or, an airbrush ink on it that says what it is. I also know when it was issued and when it expires. And that can either be the medication expiring or it can't be filled after, January 1, 2018. In fact, I can continue that further and take a look at this. So if you look at a prescription label, I apologize for those people in Europe, you don't have CVS, but, I've got a label on my particular medication. It's going to tell me who filled it. It's going to tell me what store, what the patient's name is, what the actual prescription is, how many it's got, etc. In fact, if you apply JSON to that, on the right-hand side, that's in essence what I'm storing here. And this is valid JSON, and it's valid for JOT. The thing below is the actual information that we want to carry around. And I'll get into detail about exactly what that is. So when you're thinking about this, think of it, I've got a piece of information I need to share, and I need to be able to trust that it hasn't been modified. That's the name of the game. Okay? So JOT is composed of, at minimum, two specific things, a header and a payload. The header is on the left. It describes what this is. In this situation, it is a JWT object and an algorithm for encryption. And on the right-hand side, we have the payload, some of which elements are defined, and I'll talk about that, or anything else we want to add to it. And in the case of an encryption algorithm, there is a signature that is created so that I can verify that the contents haven't been modified. And I'll get into details around how that actually works. I'll show you a little demo now. I'll do this live, but basically I've got encoded information on the left that decodes into the information on the right, which is exactly what you saw on that prescription labels slide. So think of this as in three terms. There is a header, a payload, and a signature, if you will. Let's talk about that signature. For JSON Web Tokens, it's a type of JWT, and the algorithm is one of three things. It is HS256, which is 8MAC SHA-256, it's RSA, or none. And I'll talk about the none one, because I said earlier, it is at minimum these two header and payloads. If it's unsecured, meaning the algorithm is type of none, there is no signature. In that situation, I can't verify that the payload hasn't been modified. Hence, it's completely untrusted. They talk about secure. There's nothing secure about JWT. It is clear text, base 64 encoded. So, I can decode it at will on the web. There's nothing secure about that. It's a trust issue that we're going to be talking about. So, algorithm, type none, don't do it. The specification talks about registered claim names. And these are items that were created as part of the standard that are described and maintained. So in this situation, the claim name of ISS is the issuer, and it talks about specific references to that in the document. In addition to those, there are private claim names, or anything you want to use that doesn't, A, conflict with the registered ones, and they must be unique. So you can't have multiple ISSs as part of your JSON object. It's up to the JSON parser and your implementation to make sure that that's true. There are a stack of registered claims, and I'll drill down on these because some of them are pretty darn interesting. There's the issuer who created this token, a subject, what it is, an intended audience, followed by 3 specific dates. And these are in Unix epoch time format, so they're integers or seconds since January 1, 1970. That do a number of things. One is the expiration. The analogy I was using this morning was you buy a movie ticket today for a show tomorrow. So the ticket's going to say, yep, you're going to the new Kingston movie at 7 o'clock. It's not good before or not before this particular date of tomorrow. It expires after the 7 p.m. show, and I could say it was issued at 4 o'clock this afternoon. There's also another claim of JTI, which is not Uniface Anywhere, which says this. And the reason why I put this vocabulary up here is because they go to great lengths to make some of this stuff more complicated than it really is. I pretty much understood claim provides a unique identifier for the JWT. Good. I don't need anything more than that. The identifier value must be assigned in a manner blah, 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 blah. You're just saying the same thing again in a different way. The specification reads like that because they don't want any ambiguity. Okay? The claims determine what are also optional. So you don't have to specify every one of these. And applying all of them doesn't necessarily make any sense either. So I've got the ability to create this header and payload. There's nothing to it. It's a bunch of JSON strings separated by a period. So the header, that dot between header and payload is not a separator that I put in there just for sport. It is required. Both the header, payload, and signature are all base 64 encoded. The signature just happens to be the encrypted header and payload base 64. JOSI, or the JSE, is also the ability to go ahead and put a bunch of 3-letter and 4-letter acronyms around technology just to confuse you. Suffice it to say, it's header.payload.signature. The special case is if the algorithm is of type none, there is no signature. So when I got the question on, how do you go about doing this, the first thing I did was, Google the available JWT libraries. And there are a bunch of them. They're for .NET, Python, Java, Rust, 1C, even Delphi. What was absent is, hey, where's Uniface? I didn't see a JWT library out there. And I was like, oh man, this is going to be complicated. So the first thing I did was, let's look at the C library and see if, and I'm like, time out. You're being way too technical. The spec is really straightforward. You need to create a header, you need to create a payload, you need to turn it into base 64 and assemble it together. Which is exactly what we're capable of doing in the product. So JSON creation, yeah, you can do that. You can either assemble strings up all by yourself, you can create a struct and convert it to JSON. Base64 encoding, yeah, we do that. HMAP, SHA-256, yep, we do that. And yes, I have the ability to manipulate web headers, whether that be in the actual header of an HTTP request or on the URL. All of these other technologies, are required to go ahead and implement that all kind of stuff. We don't need to worry about that. This has been in the product since Uniface 9. So it gives you the capability of doing what is necessary to implement it. I'm going to give you kind of a little scenario that is what I'm going to be demonstrating. So a typical use case is either a web application or a call to a RESTful service, for example, where I need to go ahead and make a request. My application will say, do I have a token? Where that token is entirely up to you. That can be either on the URL as part of an authorization header, stored in a cookie, or whatever other mechanism you want to use, but it's up to you to determine that. The typical web way would be to make it part of the authorization header. Somehow I need to determine who you are, whether you're a calling program, passing a user password, etc., whether you've gotten a unique identifier from me or something like that, so that I can provide information based on a trusted source, if you will. In my demo, I'll show you, I'll log in with a user and a password. I'll go ahead and pass the token back, and we can use that for subsequent calls. Now, there's some other unique things about those registered claim names. So there's an expiration check. There's the issued before or not before check. And there's the issued at. So just like buying a movie ticket in advance, my application on the other end, be it a web application, a RESTful service, or what have you, has the ability to go ahead and say, hey, I'm expired, or it's too early to use this, or wait a minute, I haven't been issued yet. And you can do those things and play with the dates and times to control what's effective for your particular application requirements. Okay? There is no defined interaction in the specification other than this is what it provides and this is a potential use case for it. So from a Uniface perspective, I've got two routines that I will be using: $encode for both base64 encoding and for encryption, and $decode for the header and the payload so that I can work with it. Now, there are a couple of other things to keep in mind. Back on the third slide, there was talk about complexity. You should not be using a token to go ahead and store every piece of information about your application and send it down the wire. That doesn't make a heck of a lot of sense. While it can be done, don't do it. So keep that in mind. We're looking for something very short and sweet. Here's my sample login page. So I accept a user and a password. I perform my login or test in this situation, and it returns me a token, and I'll demonstrate that. Followed by a little debugger that I put together to make sure that I was doing it correctly. And there are also some third-party tools on the web that'll do the same darn thing. So I want to make sure that I'm encrypting and encoding the correct way. It also illustrates that I can do stuff in Uniface just like you can do in any other technology. Okay? Make sense? Show of hands? Great. Woo-hoo! Alrighty. Let's get in a little demo. Let's shut down PowerPoint because it likes to take over my desktop. So I have my project built in Uniface 10. Curiously, it's called the JWT project. I've got a series of components out here, and I'll break those down for you. On the left-hand side, you see the JWT build is my JWT debugger. It's that encode decode screen. My JWT test is my login page, or a way to get information in. That's something you can clearly change, do whatever you want with. The JWT component is actually the component that will create tokens, verify them, and do some other stuff. And then I also put a time utility out here, because that epic time, while we can absolutely do it in Uniface, it was an interesting exercise for showing people that, yeah, proc is powerful enough to do things that you could do in any other language, including C. So let me take it from this perspective. I'm going to zoom this up here, grab my trusty browser, and I'm going to perform a test. Now, I passed my username of sample and my super secure password of 123123. It called my JOT component that in turn created a token and sent it back, and I decomposed it for you. So this token has a header, algorithm HS256, type of JWT. It's got a payload that was issued by me because I typed it in that way. It's got a subject of sample JWT. It expires on that particular epic date, which happens to be today plus 5 days. I've got my own private claim name of company. I've got a unique identifier for this, which is nothing more than the UUID or a GUID. And it was issued at that particular moment in time. Extra points to whoever's gone out to the epicconverter.com and banged in that date to find out what it is. That's because this is the token that was sent back. So if you look for the period, it's somewhere in here. I've got my header base64 encoded. I could go ahead and paste that into a base64 decoder and get that header that came up, which is precisely what I did, followed by the payload, which you saw in that message box, and then the signature. So how do I know this token has not been tampered with? Well, the only way to do that is to perform the encryption test that header and payload encrypted with my super secret key, called secret, is correct. And that's exactly what this tester does. It says, given that, decode it, come back, and I can verify my signature. Now, what I don't have to do is I don't have to provide any public-private key to anybody else. I can simply verify for my particular purposes, this token has not been tampered with, which is what you want. In addition, you're going to also want to check things like, is this token expired? Now, they also talk about refresh tokens, which, in my opinion, is kind of goofy. Because if I expire and you're just going to allow me to refresh the token and issue a new one, it didn't really expire, did it? But that's something you can also do. When I get into the code, I'll show you some of the things I did to give you the ability to go ahead and control its lifespan. Okay? So those are the two, components that you actually see. Let's get into the one you don't. So if I open my JWT component and look at my operations, there are a couple of things that you need to be able to do. Let's get into the login one, because that's the one you've seen in action. So this particular operation takes two particular methods and combines them together. There's a create there's an add to headers, and there's an authorize. And I'm just being, overly cautious here that there's a method to create that particular token. You see that $datetime plus 5 days is the expiration. Done in my own special way. This is how I want it to occur. The add to headers will go ahead and create the authorization header and either request a response. In this situation, I put it in the response so that you can grab it, or you can also just grab the token, which is what I did in the logon form. So I take the token and do something with it. And if I want to put it in my authorization headers, I can do that as well. The create is also pretty straightforward. I need to create that header. If you've used Uniface structs, you know how easy it is to go ahead and create a particular structure. I simply create a new struct using cleverly named $new struct and create 2 elements and pop values in. To turn that into JSON, all I need to do is struct to JSON, and I'm ready to go, and I can encode that. That header encoding is probably not going to change all that much because you're not really going to change your encryption method, I don't believe. The payload is also up to you. It's a matter of what you choose to put in there. However, there are some registered names, and you might as well use them. So ISS is the issuer, subject, and audience. I can apply those. That's all this operation takes. But there's some other things that if you want the thing to expire, you can set that, and I'll show you the time util to go ahead and take that date and turn it into Unix Epic. You could absolutely do $datetime plus, whatever seconds and go ahead and do that. And I did something out here, so if you specify other parameters, I'll treat it as a list, and I'll go ahead and make that part of the struct, so you could use it around. Once again, this is an example, not production. You can see my JTI being created, $UUID. It is case sensitive, but it's uppercase, and that's fine by me. So what I really need to do is create my signature, which is the header dot my payload, base 64 it, and then encrypt it and base 64 it. Okay, so I want to take those things, encrypt it. I'm not interested in decoding the encryption. All I'm interested in is creating it. When it comes time to check it, we'll compare the encryption of these 2 elements versus what was actually on the token, and that'll tell me if it's been modified. But that's all that's required. Okay, I kind of got a little carried away putting in, parameters on an operation to go ahead and do that. You can absolutely do this inline and create it any way you wanted to. Okay? Let's take a look at check expiration. So if any of you are doing RESTful services and have either seen my presentation or built your own, the mechanism that you use to send back an error, while REST defines it using HTTP status codes, they really don't do the same for Java. So there are a couple of scenarios that I want to deal with. One is there's an empty token. That's not valid. Okay? There's the header, the payload, or the signature are empty. That's not valid either. I put a check to say, you know what? If the algorithm isn't HS256, that's a problem. So I'm not even dealing with the none or the RSA. This is the one I'm going to implement, and that's exactly what you tell your consumers, that this is what you need to do. Because quite frankly, when it's issued, you're the only one that's going to be consuming it. Your target, be that someone making a RESTful call or someone interacting with your application, may choose to look at the contents of your token, but there's nothing there that they couldn't see anyways. So you're just providing, more information. In fact, you could have a token that's nothing more than a header and a JTI. Okay? I also check to make sure that the signature is computed the same. So when I sent the token out, I encrypted it using my super secret key of secret, and I checked that against the signature that I went ahead and put on the token. If those things are identical, channeling my inner my cousin Vinny, identical, I know that it has been modified. Now remember, that's not true with the algorithm of type none because there's no signature. And then they do a couple of other things. So, in my particular use case, I'm saying that the expiration, is plus or minus 10 minutes. Actually, it's plus 10 minutes. So if it's within that range, you're good to go. And the not before, I'm giving it 30 seconds. That's just something I pulled out of, the blue to make sure that, it was a little slow or too fast. I want to make sure that someone can use what I want them to use. If they're not present, you don't process them. So they're optional for both in the payload and what you do with them. My assumption is if you put something in there, you want to have it used. Okay? Now, I just chose to use 400 as a status code. In your environments, that's going to be whatever you want. It should be something in the error range. A 200 probably would be bad because you're looking to go ahead and make sure everything's cool and groovy. Okay? And let's look at this one. So if you were not doing this in Uniface and you were doing it in some other implementation language and you wanted to add the authorization header, this is exactly what you'd be required to put. It's authorization : space bearer space in the token. I went ahead and flush the cache as well, but that's not necessary. But that is the way you put it out there. The way we do that in Uniface is using the request header or response header, depending on what you want to deal with, and the token itself. Now that means that your application will look into the authorization header and grab that token and do what it needs to do. If you chose to say you specify the token on the URL, which you can do because it's base64 encoded, that's fine. If there's some other mechanism you want to use, that's fine as well. So it's not dictated by the standard how you go ahead and do that. Okay? Let's also get into the time util. And this is shameless from my perspective because I literally took 2 C routines and directly translated them to Uniface. Once again, the purpose being to show people who are not familiar with proc that I can do the exact same things that you're doing in a 3GL in proc. Mike's waving his hands to make it bigger. I was not being telepathic. Okay? Down to, compute leap days, leap years, all that fun stuff. I did a similar exercise with Metaphone. I took the C routine and converted the C routine directly to proc. So a lot of this stuff you can do. It shows people the power of the language, etc. As I said, you can do this stuff directly in proc if you wanted to. They wanted me to get paid by the line of code I wrote. And comments count. Okay? Now, I'm unable to see the chat window, so I'm assuming that nobody has any questions, which I probably find hard to believe.
Well, we had lots of questions this morning, but not this afternoon.
The question you should be asking is, where can I get this? Anybody want to know the answer?
I've already told them.
Oh, darn. They weren't paying attention.
Somebody's coming.
Yep. I'm just looking for any additional questions. Anybody find this helpful? Sorry, Yearly.
Okay, looks like we're wrapping up. So,
Alrighty.
Just to confirm, the Tom's demo and the presentations will be packaged up and made available online. We're going to use probably a combination of Git and Uniface.info samples for the actual program. Tom's presentation will be put up onto SlideShare, and the recording of this session will be put onto YouTube, if not by the end of this week, early next week. So everything should be available for you all. We'll say thanks to everybody for attending. Thanks for Tom for coming over and doing the 2 sessions. And next month we will continue with our sessions around security. So thank you, everybody.